Welcome back to the LRC, anyone brave enough to watch this video. This is all of the separated footage from our last video showcasing how to answer a advanced word problem that uses all of the formulas we discussed. It's around 8 minutes worth of content and I hope you guys enjoy. Now that we're done with that, let's move on to using Gressa for a harder problem, a multi-step problem, this problem. So this problem is a lot to digest, but the first thing you have to know about multi-step problems is you solve it alphabetically. So the first thing you're gonna want to do is you look at the question here. Question here says that for after the first 10 seconds, what is the motorcycle's velocity? Because we know that, we can then substitute that. Let me just erase everything here. Uh, but since we know that, we can substitute the required as velocity because we're answering the first question first. So v is equal to, and now we know what we're doing. After that, we look at the problem and look for what it gives us. The first thing it gives us is its acceleration. It accelerates uniformly at 2 meters per second squared east. Um, so that's also how we know its velocity because it gives us a direction. But anyways, our given now is acceleration is 2 ms squared. I'm not gonna add the east because it's already implied in the problem. Instead, what you can do is in the answer portion, you put the direction the car is going in. But just for convenience purposes, I'm just gonna put the numbers here. After that, we also know the amount of seconds this car accelerates for. We know it accelerates for 10 seconds. Uh, Time is equal to 10 seconds. And this question specifically asks, after the first 10 seconds, what is the motorcycle's velocity? So we know that's the actual time the problem gives us. Okay, now that we're done with this, we are going to have to use our equation. But the first thing you're gonna ask is, I didn't really teach you how we can apply this equation in this scenario, right? However, using a bit of logic and what we know from acceleration, we can kind of just um, decipher what this problem is asking, right? This problem is asking the velocity, and we know that acceleration is something that shows us the rate of change and how much faster or slower something gets per second. And because we have the exact time here, we'd be able to write that velocity is equal to acceleration times time. The reason this is because acceleration in this scenario shows us that the car is going 2 meters faster per second. And we know that after 10 seconds, it stops accelerating and goes at a constant velocity, which means if we just multiply these two numbers, we'll be able to find the speed of the car at the end of the acceleration. I'm not gonna spoil it actually. I almost did, but we'd be able to find the speed of the car at the end of the acceleration, which is, in other words, just velocity. Uh, okay, so we have our equation. It's velocity is equal to acceleration times time. Um, our solution then is to substitute this with real numbers. So we have 2 parentheses 10, and then we just multiply that and we get 20 ms. And after that, we get our answer, which is velocity is equal to 20 m. Ooh, that's 2. Velocity is equal to 20 ms east. Okay, now that that's done, let's answer the second problem, B. What distance does it cover while moving at constant velocity? Um, Now, like what I said, a lot of what we put in Gressa depends on the problem itself. Since it's a multi-step problem, you get like a lot of pieces of information. But something like the deceleration is not really needed right now. We just need to think about this part. So the first thing it asks us is, what distance does it cover? That's the question, which means it is what we have to put in required. Let me just erase all this first. So because of that, we know that we have to put here distance is equal to question mark. After that, we have to find the conditions the problem gives us, and it says here that this is while the motorcycle is moving at constant velocity. So because it says that, we know that it's talking about the part in the problem where it says the motorcycle is continuing at a constant velocity for 15 seconds. So that means we have our time, 15 seconds, and we have our velocity, which is the answer to the first problem, 20 ms. Okay, Now that that's done, this is actually a more normal problem. Since we know this is actually displacement, not distance, this was a small error. But just using the triangle, we know that the equation for this problem is going to be distance is equal to velocity times time. Sorry, displacement is equal to velocity times time. And just substituting the regular numbers for that, we get 20 times 15. And doing the math for that, we'd get distance is equal to 300 meters. And now we can add here 300d is equal to 300 meters east. Remember that you kind of have to add the direction it's going in here because this is displacement, so it's a vector quantity, which means you have to add east. But yeah, distance equal to 300 meters east. Now let's go on to the last problem, which is unfortunately the hardest one. How long does it take to come to a stop as it decelerates? Now, we already have our pieces in play, but the first thing we have to ask ourselves is, what is decelerate? Decelerate is basically just negative acceleration, which means you can just treat the same as acceleration, just make it negative, right? So it says over here in the problem that the motorcycle decelerates uniformly for 3 meters per second squared. So we put here that the acceleration equal to negative 3 meters per second squared. And then it says it comes to a complete stop. Now, the interesting thing about complete stop is we can assume that this is the final velocity, and that means that the final velocity of this problem is just 0 meters per second. We also know the initial velocity because this is straight after the constant velocity. And we already calculated for the constant velocity. The constant velocity was 20 in both problems 1 and 2. So the initial velocity here is 20. Now, all we're trying to find is the time. It says here it's a how long problem. So we put here time equal to question mark. Now, if you remember, our initial formula over here was acceleration is equal to Vf minus Vi times time. The coolest thing you can do now, though, is you can do something known as algebraic manipulation. If you multiply time by both sides, you'd be able to cancel out time from this and get At is equal to Vf minus Vi. And now, if you divide A, you'd be able to cancel out A on this side and get time is equal to Vf minus Vi. If you don't know why that is, I suggest you check out our algebraic manipulation video. But just assuming you guys already know basic algebraic manipulation, this is now our new equation. So because of this, we can kind of solve this normally. We get time is equal to 0 minus 20 divided by negative 3. And since it's negative numbers, both of these are negative numbers, it would lead to a positive result, which is good because there's no such thing as negative time. So you divide both of this, and you get 6.66, which also evens out to t is equal to 6 point, wait, 0.67 when you round it up. And so our time is 6.67 seconds. And that's the answer for C. Okay, that was a pretty long video, and that's a lot of stuff. So just to make sure you retain all of that and understand all of it, we have some problems for you, extra exercises. And here are 2 advanced problems. This is A and this is B. Okay, all of these are going to be in the description, so I don't need to take a screenshot. That's the end of the video. I hope you guys enjoyed, and see you guys next time.